Standing on the shoulders of giants. This is the story of PostNL, how we embrace serverless technology, what it has brought us, but also the challenges we faced and how we overcame them. And before we start, I must warn you, this is not going to be a technical talk. It's about large organizations and modern software. It's about people and culture, learning and development. And I think if you're looking for a more technical talk, there's enough today to scratch that itch. My name is Luc van Donkersgoed, and as Matt already said, I'm a AWS serverless hero. I build awsnews.com on the side, and I'm a principal engineer at PostNL. And PostNL is the Dutch national postal service. On an average day, we process 1.1 million parcels. We have 37 sorting centers, and we employ over 33,000 people. So, in other words, we have a pretty big logistics network. And this logistics network is powered by advanced algorithms and processes. And the application landscape powering these processes consists of over 70 applications, which are built and maintained by over 30 in-house development teams. Now, PostNL is also kind of an old company. We can trace our history back under various names to 1799. So this year, we're celebrating 225 years of logistics history. Now, of course, you don't get to the ripe age of 225 without adapting to constant change. So over the centuries, among other things, we've adapted from horses to cars, from physical post offices to the internet, and from letters to parcels. And in the past few decades, software, of course, has become an inextricable part of PostNL's operations. But the way we approach software has significantly changed since 2012. Because before 2012, we mostly used commercial off-the-shelf and vendor-built solutions, which were hosted in our own private data centers. And in 2012, we decided that, well, maintaining data centers should not have our core focus. And we migrated everything to AWS, making us one of the first European enterprises with a public cloud-only strategy. Then in 2018, we realized that to remain competitive in a fast-moving environment, we had to build our own software. In other words, we had to become a software engineering company. We explored our options, and we found that serverless and cloud-native solutions on AWS were the best fit for our business. So we optimized our teams and our platforms to make the best use of these technologies. So, why choose serverless as the foundation of our new engineering strategy? Well, there are a few reasons. And the first is elastic pricing, or pay-per-use. And this is very relevant to our business because in an average week, the load on any of our applications might look like this. And as you can see, we hardly process any requests during the nights and on Sundays. But during the weekdays, and especially on Tuesday, around noon, we experience very high loads. Because this is when all of our delivery drivers are out, but also when our consumers and customers are using our apps and websites. Maybe they're tracking where their parcel is and so on. But because our entire landscape is serverless, we hardly generate any cost during these off-peak hours. And with these kinds of patterns, that can lead to very big cost savings when compared to more classic always-on systems. Now, the next reason to choose serverless is effortless scaling. Now, of course, scaling is an important property to have when you have usage patterns like this. But this weekly seasonality is not the only seasonality that we see at PostNL. Here is another usage pattern, and this time it covers about 6 months. You can still see the same weekly pattern because each of these bumps is a single week, but you can also see another pattern, which is increasing load towards the end of the year. Now, can you take a guess what causes increased load towards the end of the year? Christmas, of course. So in November and December, for us it actually starts at Black Friday in November, and it goes all the way up till Valentine's Day in February. But especially in November and December, we see increased load, about twice as high as what we see in the summer period. And even in the months afterwards, in January and February, we also see increased volume because of more return parcels being sent back to the web shops. But by embracing serverless, we don't have to think about this increased scale because our applications automatically adjust to the increased load. Now, of course, our AWS bill will be higher, but we're also generating more revenue. So the higher AWS cost is automatically covered in the higher revenue. And what's a very important metric for us is the price per parcel. And because the infrastructure scales with the volume of parcels, the price per parcel stays about the same. So we've covered elastic pricing and effortless scaling. And of course, these are two very important properties to have in a serverless landscape. But to me, they're not even the most important aspects of a serverless environment. So let me ask you another question. Can you tell me what the two most expensive components of software engineering are? Salaries, people is absolutely the number one. And the second one is incidents or outages. So let's cover those topics. The most common cause of outages worldwide are infrastructure problems. So we might talk about physical hardware failing, or maybe a hard drive filling up, network congestion, or misconfigured networks. I mean, how many of you have experienced a network problem caused by DNS or BGP, right? Those are the things that bring down really big systems. In fact, there are so many moving parts to infrastructure that building and maintaining enterprise-grade infrastructure is a very valuable or costly, depending on how you look at it, specialism. And as an enterprise, you have no choice but to do it right. Because outages are super expensive too. In our case, we have this very large logistics system. And if that system goes down, then our 37 sorting centers might not be able to work. Our 33,000 employees might not be able to deliver the parcels to the customers. Or maybe these customers might demand compensation for parcels not delivered or not delivered on time. So incidents are very expensive. And this also means, because infrastructure is so important, that if you make your application builders responsible for their own infrastructure, it will take them significant time and effort to build and maintain that, which is time and effort that they're not spending on creating customer value. Now, of course, you could create dedicated platform teams or operations teams that build this entire infrastructure for them, for these teams to use. But then these teams, these operation teams or platform teams, are super expensive too. And they also have to do a lot of complicated operations. And remember, we moved away from data centers because we figured it's not our core focus to maintain a data center. And we apply the same principle to platforms. So instead, PostNL chose to mandate the use of serverless. And this allows us to delegate the most difficult infrastructure problems to AWS. So for example, we don't think about physical CPUs. We don't think about their capabilities, their compatibilities, their instruction sets, or any of that. We just use Lambda or Fargate or step functions, and AWS manages the underlying physical capacity. And likewise, of course, we still have a network to communicate between our applications and services, but we don't think about bandwidth or throughput or speed or the kind of foundational protocols that power these networks. We just use the AWS network, and they can handle any volume that we can send to it. And then the third topic is high availability. Of course, this is a very important but also very complex topic. It involves availability zones, multiple regions, failure detection, failover, immutable resources, and many more complex topics. But with serverless, we just get all of this out of the box. We just write an object to S3 or a message to SQS, and Amazon takes care of the rest, and they take care of the high availability. And then finally, another great benefit of using managed services is the security responsibility carried by Amazon. For example, when the log4j vulnerability was found, they patched their applications, their operating systems, their platforms, their runtimes. They even patched the AWS Lambda service to protect customer application code from abuse. And likewise, when the Heartbleed vulnerability came out, they patched their underlying physical infrastructure, and there was no customer action required. So these are all things that we as an organization do not need to think, or at least not as much of anymore. And I think this diagram is a great way to tell that story. All the way on the left, you have on-premises. And now as an enterprise, you're responsible for the entire stack. You're responsible for the power supplies, the internet connectivity, the data centers, the security, the virtual machines, the entire thing. Well, all the way on the right, we have serverless, and now Amazon is responsible for almost the entire stack. They do the data centers, they do the virtual machines, the operating systems, the platforms, the runtimes. And if you use truly serverless applications like SQS or DynamoDB or S3, they even take care of the entire application for you. They just give you an API endpoint, and that's all you need to use. So, what are the results? After 5 years of using serverless, at PostNL we have significantly reduced the number of incidents and outages. We've also created dozens of teams which have created thousands of features over the years. We've also brought down overhead, both in a productivity as well as in a financial sense. And because we moved many of these development teams in-house, our teams are now much better aligned with strategic and organizational goals. So we embraced cloud-native services, and we never looked back. It's all roses and unicorns and serverless land, right? Or is it? Of course not. Because nothing good comes without a cost. So let's talk about trade-offs. As anyone here in the room will probably tell you, everything is a trade-off. So embracing serverless is no different. And there are many arguments that you commonly hear against serverless. So let's talk about a few of these arguments, but consider them as trade-offs. What do you lose and what do you get in return? The first argument commonly heard is that serverless locks you in. This is probably the most commonly heard argument against serverless. And honestly, I'm not even going to argue. It's true. If you embrace the AWS serverless ecosystem, leaving AWS is going to hurt. But what is the alternative? You can try to avoid AWS services as much as possible. Well, good luck trying to avoid IAM. Or you can maybe try to use another platform like Kubernetes to take a lot of the responsibilities for you. But have you seen the operational complexity required to run enterprise production workloads at our volume in a Kubernetes environment? Right? If you take that route, again, you're taking on the entire responsibility of building and maintaining and patching and securing that platform yourself. And that's exactly what we're trying to not do. So with serverless, yes, you're locked in. But as a trade-off, you get to delegate all of that platform maintenance to AWS. Now, the second argument is that serverless is expensive. People say that running enterprise production workloads on it will break the bank. And in this case, I might agree on the price per event or the price per request or the price per gigabyte of data stored. But again, this is a trade-off. Because for this price, you get all of the benefits that we discussed earlier. You get scalability, maintenance, security. You get hundreds of new features every year. And this at no additional cost. It's all included in the price. And also remember the price of outages and incidents that we discussed. If you include all of these values into your total cost of ownership analysis, you might find that the higher price per request or per gigabyte stored might be well worth it. Then the third argument is that serverless is too complex. Running a small application on serverless requires at least 4 services, and you need to know how they scale, how they fail, what their limits are. But I would argue that this complexity and the need to be aware of how these services work is actually a good thing. Because in fact, if you run the exact same application on your private data center or on EC2 or on Kubernetes, you will likely use exactly the same components, but they might be hidden in the infrastructure or hidden in your application. Which means, again, that as a builder, you're responsible for building or for maintaining these components, even if you can't see them. And serverless brings this complexity to the surface, right? Where it's visible, where it can be debated, where it can be analyzed, where you can think about the effects of these components and the requirements, all while Amazon remains responsible for their operations. And then finally, an often heard argument is that serverless is too opinionated. And again, I'm not going to debate that serverless is opinionated. It is, and very highly so. But most of the time, I'm saying most of the time, not all of the time, this is with good reason. Because the limits and restrictions imposed by these opinionated services might protect an internal architecture, or they might protect customer data in a multi-tenant system, or they might protect an internal architecture, make sure that you use the application the way it was intended. So the way we see it at PostNL is that it's better to try to work within the limits of an opinionated system, try to understand them, than try to work against them. So let's explore this topic of opinionated services a little deeper. It's no secret that Amazon builds services and applications for skill, right? For example, Amazon S3 processes 100 million requests per second. DynamoDB processed 146 million requests per second during Prime Day 24. And Lambda, I saw this metric earlier, I think in Emily's talk, processes more than 10 trillion invocations per month. I don't even know how many zeros there are in 10 trillion, but it's a large number. Now, running infrastructure at these scales, of course, requires very strict architectural principles and operational excellence. So, AWS has decades of experience in building, designing, maintaining, running the largest applications in the world at a scale almost no one else operates at. They have experienced firsthand what works and what hurts. And the services in the serverless ecosystem are the embodiment of this experience, right? It's ingrained in their architectures. So by using serverless to its fullest extent, by embracing serverless, your applications automatically gain a base level of maturity that typically takes years to build. Now, in the end, PostNL's approach to serverless comes down to this. Our operational systems need to be available at all times under pretty much any load we can imagine. Distributed, decoupled, and elastically scaling serverless architectures help us achieve this goal. They greatly reduce the operational burden and the number of incidents that we experience in our architectures. In other words, they reduce runtime pain. But to get these benefits, you need to invest at build time when you write and design your applications. So, embracing serverless does have an impact. If we're going to use serverless to its fullest extent, we need to know its capabilities inside and out. If serverless is expensive, we need to know how to optimize for cost. If serverless is complex, we need to train our engineers. And if serverless is opinionated, we need to know the rules of the game so we can use them to our advantage. So what does this mean for the serverless engineer? The engineer building the applications at PostNL. What skills do they need? What challenges do they face? Of course, they need to be very familiar with the serverless ecosystem. They need to know about the available services, their use cases, their limitations, their failure modes, and maybe how multiple services that look a lot alike compare to each other. Like, when do you use SQS? When do you use SNS? When do you use EventBridge? When do you use Kinesis? They're all message integration platforms. Then our engineers also need to be able to design for skill. For example, they need to think about queues, about buffers, about exponential backoffs, about throttling, and all of the challenges that come with high volume systems. At the same time, they also have to keep on designing with cost in mind. Of course, our engineers could just store any parcel update in DynamoDB. But would that really be the most efficient solution? Is that really what you need? Maybe an alternative solution using, I don't know, Kinesis Firehose based on S3 could be used to solve the same problems more efficiently. And then finally, our engineers also need to think about the operations of their workloads. Which metrics are important? What alarms do they need to configure? How are they going to make their applications observable, right? This is all part of their responsibilities and skill sets. So in summary, our engineers need the knowledge to know what tools and services are available to them. And they need the experience to make the right decisions. And this is not easy. It requires long-term investment in people and culture from our side, from PostNL's organizational side. And one of the ways we do that is by investing heavily in formal education, such as classes and workshops for our engineers. We also foster our engineering community, making sure that our engineers work together and share what they learn. We have knowledge shares every 2 weeks in the office. And we have tech improvement charters, which are led by the engineers for the engineers, where they determine what our shared platform looks like. And we have found that this continual learning and sharing our experiences is essential to building a cutting-edge software company. But at the same time, we've also seen that a very effective way to promote good serverless engineering is to make the right thing easy. So for example, we offer one-click solutions to deploy new AWS accounts so that you get these separation of accounts, separation of workloads over different accounts. And when you deploy these new accounts, we automatically integrate it into our networking architecture, into our security tooling, into our cost monitoring tooling, and even our CI/CD pipelines, right? Make the right thing easy. But of course, we also need strict guardrails. We also need to determine what they cannot do. So for example, we have service control policies in place, and I really liked Tom's talk this morning. He said exactly the same thing. We have service control policies, we have permission boundaries that limit what our users can do within their environments. And in our case, we prevent the creation of EC2 instances, so we enforce that they use serverless technologies. We also prohibit the creation of IAM users because they have long-lived credentials. That's a security risk. We enforce the use of IAM roles across the entire landscape. And this forces our developers to make the right decisions regarding cost, security, and operational overhead. So, what have we learned? Well, embracing serverless in the enterprise is good for reliability and for cost. But embracing serverless is not a flick of a switch. You don't decide to be a serverless enterprise and ta-da, you're it. It requires long-term investment in people, in culture, in processes, in guardrails, and in the AWS platform itself. You need to make the right thing easy and the wrong thing hard. And of course, most of all, you need to hire and train the experts who can build your serverless future. We have seen that the more we invest in serverless, the more we can delegate to AWS. They become responsible for almost the entire stack, including its security, reliability, and scalability. And because serverless services are built to perform well under the highest workloads imaginable, and they have decades of experience ingrained in their architectures, we have found that by embracing serverless, we truly get to stand on the shoulders of giants. Thank you.